Hi everybody. I just wanted to make a quick review video as promised on a couple of the concepts that some people have been struggling with in the last couple weeks with patternings and algebra and algebraic rules. So I'm going to take a step back and review some of the things we've already talked about, and you can use this video sort of to review and study for your upcoming test on Thursday, as well as to complete some of the practice questions on the practice quiz that I put on our Facebook page if you wanted to do that. So let's get started. Here's a sample problem, or pattern I should say, that might appear on your test. And what I might say to you, or what we would say to you back in grade 4, would be what might be the next three numbers in the pattern. And so we're looking for you to see, can you tell how this pattern is changing, if it's increasing or decreasing? Well, the numbers are getting bigger, they're getting greater, so we know that the pattern is increasing, and you probably have already realized that the pattern is increasing by 3 each time, so that you could probably add 3 to the next values, the next 3 values. And now that's good to understand that the pattern is increasing by 3 each time. However, if I asked you what is the 63rd number in this pattern, that would take you a really long time to draw out this pattern all the way to 63 to figure out what that number would be. Or if even greater, what if I said, what's the millionth number in this pattern? So this is not an effective strategy to just increase and increase and increase and increase. It's good when you're finding, the next 3 or 4 numbers in a pattern, but it's not good if you're skipping ahead in the pattern trying to find any number in the pattern. For that, in order to do that, we need to know what the pattern rule is for this pattern. The rule is being applied to every single number in the pattern. That's what makes it a rule, and that's why it's a pattern. If there was something different going on every time, then it wouldn't really be a pattern. It would be random numbers, and there would be no rule for it. But if there is a constant change in the pattern that we know and we can predict, then we know that there must be a rule that governs that pattern. So in order to figure out that rule, we use a T-chart. It's one of the strategies that we use. And I showed this to you in a couple of different ways. You can either think of this in terms of the term number and term value. That's how I want you to think of it. But you can also think of it in terms of the number going in and the number coming out. Okay? Kind of like a computer. So when I put this number in, this number came out. Now, the number that I put in is the actual position in the pattern. So the first number in the pattern is the number 7. Okay? And the second number in this pattern is the number 10. And the third number in this pattern is the number 13. And the fourth number in this pattern is the number 16. Okay? So you'll notice here's our pattern right here, 7, 10, 13, 16, 7, 10, 13, 16. I've just taken the pattern, and instead of writing it like this, I put it into a table and I'm writing it vertically like this. Okay? Now, after I've kind of set up my T-table, or my in and out table, I'm going to look for the common difference, which we've already done up here. This one's pretty simple because you can see it immediately. But you can tell that this pattern is increasing, and it's going up by 3. Every time I add the next number, it's always going up by 3. So we call this, because it's always going up by the same amount, the common difference. So the common difference in this case is 3. Now, why is that useful? Well, this tells me if I'm constantly adding 3, adding 3, adding 3, if I have that repeated addition of a number, that's actually multiplication. If I add 3 6 times, I've really multiplied 3 6 times. So adding 3 plus 3 plus 3 plus 3 plus 3 plus 3 6 times to get 18 is the same as 3 times 6, which is 18. So this finding the common difference tells us what the beginning of our pattern rule is. So let's keep that in mind for 1 second. I know that this is going to help me find the beginning of the pattern rule. Well, what else is the beginning of the pattern rule? The beginning of the pattern rule, if you think about it as an in and out table or an input-output table, the beginning of the pattern is this right here. So whatever number I put in, I have to multiply it by 3. So this is where we start to introduce letters, variables that stand for a value. In other words, any number, any term number that I put in, I'm going to multiply it by 3. This is the beginning of my pattern rule. Term number times 3. But that's not the only thing that's happening in this pattern, because if it were, then when I put in a 1 and I multiply 1 times 3, I should get a 3. 1 times 3 is 3. But instead, my pattern starts at 7. The first number that came out of this rule after I put in a 1 is a 7, not a 3. So I must have done something else to this pattern rule. Well, how do I get from 3 to 7? I must have added 4. So that's the second part of the pattern rule. The pattern rule for this whole table is take whatever term number you're at, multiply it by 3, and add 4 to it. So what would the fifth number in this term table be, in this t-table be? Well, the fifth number would be 5 times 3, which is 15, plus 4, which is 19. And see, that's consistent. It's going up by 3. Okay, let's get a little bit more complex. What would be the 21st number in the pattern? You see how I can skip now? I don't have to write all the way down to 21 to figure out the 21st number because I know the rule for the pattern. I know that the 21st number is going to be multiplied by 3, and then I'm going to add 4 to it. So 21 times 3 is 63, and 63 plus 4 is 67. I know that the 21st number in this pattern, if I wrote it all the way out, would be 67. All right, let's try another example. Let's do this. How do you do this one on your own? Take a second, create a T-chart, and tell me what the 10th number in this pattern would be after you found the pattern rule. Pause the video for a second, and when you're ready to take it up, unpause the video. Okay, so hopefully you took a second to figure that out. You can probably already see, just by looking at the pattern and being observant, that it's going up by 4. That's great. However, I want to create the pattern rule for this pattern. So I'm going to use the term number and the term value. So the first term number in the pattern has a value of 2. The second term number in the pattern has a value of 6. The third term number in the pattern has a value of 10. And the fourth term number in the pattern has a value of 14. Okay? I've started my t-table. Second step, look for a common difference. So from 2 to 6, I've added 4. I've increased by 4. From 6 to 10, I've increased by 4. From 10 to 14, I've increased by 4. So I can see that the common difference, it's always going up by 4. The common difference is going to be 4. It's changing by 4. There's a difference of 4 numbers between each value in the pattern. All right? So what does that tell me? That tells me the beginning of my pattern rule. Hopefully you figured out that that means that the term number is being multiplied by 4. That's the beginning of the pattern rule. But if you apply that only to the pattern, to the term number, you don't get the right result because 1 times 4 is 4, not 2. So something else must have happened in our pattern rule. We can't just multiply by 4. How did we go from 1 times 4 is 4 and end up with a 2? Well, we must have backtracked. We must have subtracted 2. So this is our pattern rule. Take the term number, whatever term number, multiply it by 4, and then subtract 2, and that will tell you the next value in the sequence. So let's just try that and make sure the other ones are right. Well, 2. 2 times 4 is 8, minus 2 is 6. That's right, that's what we got. What about 3? 3 times 4 is 12. 12 minus 2 is 10. Yep, that's what we got. And 4. 4 times 4 is 16. Minus 2 is 14. That's what we got. I'm confident this is the rule for this table, for this pattern. So if that's the rule, what's the 10th number in the pattern? If I increase this all the way up to 10, what would be this 10th number? Well, let me just put it into my pattern. 10 times 4 is 40. Minus 2 is 38. The 10th number in this pattern would have to be 38. Notice how that's a much faster way of figuring out any number in the pattern once you know the rule, instead of having to increase this table all the way to 10 or 30 or a million or whatever. Okay, so I hope that helps review this concept. I'm going to make another quick video on the algebra part, solving for a variable, if you want to have a look at that one.